These are the examples for Algebra 1A, Credit 5, Lesson 11.2. Lesson 11.2, we're going to continue solving systems of equations. In the last lesson, we solved by graphing. This lesson, we're going to be solving by substitution. So the way substitution is used, you need to have one variable in either equation that's isolated or solved for. And we have that in the first equation, y is by itself on the left-hand side of the equal sign. Y equals 4x minus 11. So we can take that 4x minus 11 and substitute it for y in the other equation. So let's go ahead and do that. So we're just going to be copying down the second equation, but again, in place of y, we put 4x minus 11. Let's give ourselves a little more room there. So you might want to pause or rewind the video just to make sure you understand that. But all we did was copy down that second equation, except in place of y, we put the 4x minus 11. How come we did that? Because y is the same as 4x minus 11. All right, so now we're going to distribute 4 and bring down the 3x. 4 times 4x is 16x. And then 4 times negative 11 is negative 44. All right, so now time to combine like terms. And so let's go ahead and do that. Our x is 3x plus 16x is 19x. Minus 44 equals 13. Now x is over here on the left-hand side, so we're focused on the left. The opposite of subtracting 44 is to add 44. The 44 is canceled. 13 plus 44 is 57. Our final step, x is being multiplied by 19, so we're going to divide by 19 to both sides. Remember, multiplication and division undo each other, or they're opposites. And then the 19's cancel, and 57 divided by 19 is 3. Now remember, we're solving for both x and y, so we're not done yet. We know that x is 3. We can use either equation to solve for y. It's going to be a little bit easier with the first one since y is already isolated. So we got y equals 4x minus 11, but we know that x is 3. So 4 times 3 is 12. And then 12 minus 11 is 1. So y is 1. So now we typically want to write the answer as an ordered pair. You're going to be asked to do that in your packet. Remember, in ordered pair, x is first, then y. So writing this as an ordered pair, we would have 3 and 1. And so the answer to our first example is 3, 1, or x is 3 and y is 1. All right, so our example for number 2, another similar situation, but just doing a few of these and one that's like each problem, so just we get comfortable with it. Now, what's a little different here is that y is solved for not in the first equation, but in the second. And so that's what we're looking for. Y is equal to 2x plus 5. So we're going to take that and substitute it for y in the first equation. So what we're doing now is we're copying down that first equation, 2x plus 5. Now again, in place of y, we're going to substitute the 2x plus 5 equals 11. So again, first equation, except instead of y, we have the 2x plus 5 there. All right, so let's go ahead and distribute and see what we got here. So we bring down the 2x. 5 times 2x is 10x. And then 5 times 5 is 25. We bring down that minus 11. Combining like terms gives us 12x. 2x plus 12x is, 2x plus 10x is 12x. Plus 25 equals negative 11. Our next step, we're focused on this left side because that's where x is. We got to get rid of this plus 25 first. So we subtract 25 to both sides. 25's cancel. We bring down that 12x. Now over here, the signs are the same, so we add the 11 and 25. That's 36. They're both negative, so our answer is negative. And then our final step to solve for x is being multiplied by 12. So we divide by 12 to both sides. And negative 36 divided by positive 12 gives us -3. So that's our answer for x. By the way, just thinking about it, probably shouldn't be boxing these because typically we do that when it's our final answer. So we're just going to maybe underline them. We'll even go back here to our first one and do that. Because our final answer is writing these x and y answers as an ordered pair. All right, so again, we can use either equation to solve for y. It looks like this time the second equation is going to be easier because y is solved for. So we have y equals 2x. Make sure we can see that okay. Let's bring this over here a little bit. X, remember, is -3. So 2 times -3 plus 5. Order of operations says we multiply before we add. 2 times -3 is -6. -6 plus 5. Signs are different, so we subtract the 6 and the 5. That's 1. The larger number is negative, so that's why it's a -1. So our answer for y is -1, and then writing that as an ordered pair, putting x first, we have -3 and -1. So our answer there, -3, -1. All right, so now let's go ahead and flip the page over to page 27, and let's do an example for problem number, well, for both 3 and 4, but starting with number 3. So let's get rid of all this here. And here we go for problem number 3. So our example for problem number 3 is we have x equals -4y plus 1, and then x equals 3y minus 6. Here we go. All right, now notice that x, for the first time we have not y, but x solved for here. And x is solved in both equations. So what do? Well, it actually gives you a choice. You can do this either way. And so let's go ahead and x is equal to -4y plus 1. Let's go ahead and take that and substitute that for x in the second equation. So now substituting for x in this second equation, we have -4y plus 1, equals 3y minus 6. And so again, what we did there is we wrote down this second equation, but instead of x, we substituted in -4y plus 1. All right, we have variables on both sides. Remember, when we have variables on both sides of the equation, we don't want that. So it's a little bit easier if we get rid of the term that has the smaller coefficient. -4 is smaller than +3. So we have -4y. The opposite of subtracting 4y is to add 4y. The 4y's cancel. We bring down the 1. 3y plus 4y is 7y, and we bring down that -6. Now y is over here on the right-hand side, so that's where our focus is. First thing we have to do is get rid of this -6, so we add 6 to both sides. 1 plus 6 is 7. We bring down the 7y, and of course those 6's cancel. Last step, y is being multiplied by 7, so we divide 7 to both sides, and y equals +1. Now remember, we still need to solve for x. We can use either equation to solve for x. Let's maybe use the second one here. So let's see, we have x equals 3y minus 6, but remember y is +1. So we substitute 1 in for y. 3 times 1 is 3. And then 3 minus 6, again, the signs are different, so you subtract. 6 minus 3 is 3. The larger number is negative, so -3. Now, even though we solve for y first, when we write our ordered pair, we always put x first. So x is -3, y is +1. And our answer, -3 and 1. In other words, if we were to graph these two lines, they would intersect at the point -3 and 1. All right, let's take a look at an example for problem number 4. Now, we've had positive answers, we've had negative answers, and now we're actually going to see some decimal answers finally. A lot of times, so often the problems come out to be whole numbers or integers. We think if we get a decimal that we're incorrect, but let's go ahead and take a look at a situation where we are going to get a decimal as an answer. And so this is going to be our example for problem number 4. And also for your problem number 4, the answer will come out to be a decimal. All right, so we have 5x minus y equals 14, and then x equals y minus 8. All right, so the variable that is isolated is the x in the second equation. And so we're going to take y minus 8 and substitute that for x in the first equation. So let's go ahead and do that. So we're copying down our first equation here, but in place of x, we're going to substitute y minus 8. And then everything else we just copy down. So we have 5x, but x is y minus 8, minus y equals 14. All right, let's go ahead and distribute and start the solving process here. 5 times y is 5y. 5 times negative 8 is negative 40. And then everything else, the minus y and the 14, we bring down. We do have a pair of like terms to combine our y's here. 5y minus y, remember that's a 1y. So 5y minus 1y is 4y. We bring down that minus 40, and that's equal to 14. So now we're focused over here on the left because that's where y is. We start with our subtraction first. The opposite of subtracting 40 is to add 40 to both sides. So let's go ahead and do that. The 40s cancel. We bring down the 4y, and 14 plus 40 gives us 54. All right, our final step is to, well, you know what? Actually, let's fix this here. This was supposed to have been a negative 14. So now this is another good example. We didn't do this on purpose. But if you make a mistake, you don't have to erase the whole thing. Now, I had written the problem down wrong by leaving off the negative, so let's just follow that down. So 14 hasn't been affected till now, so all we need to do is just make that a negative 14, and we're good. So actually, that's going to change our answer here. Negative 14 plus 40, the signs are different, so we subtract. 40 minus 14 is 26. The larger number, the 40, is positive, so positive 26. Last step, y is being multiplied by 4, so we divide 4 to both sides. The 4's cancel. And now 26 over 4, you could simplify that to a fraction. You could divide by 2, you'd have 13 over 2. But this one, let's just do this as a decimal. 26 divided by 4. So remember, to convert a fraction to a decimal, the fraction bar indicates division. So 26 divided by 4 gives us 6.5. So as promised, our answer, at least one of them, is a decimal. Let's see about the other one here. So we can use either equation to solve for x. Probably a little bit easier if we use the second equation. So because x is already isolated. Y is 6.5. So we have x equals 6.5 minus 8. And signs are different. So we subtract 8 minus 6.5 is 1.5. However, the larger number, the 8, is negative, so that's going to be a negative 1.5. And so our answer for x, negative 1.5, writing that as an ordered pair, always putting x first, we have negative 1.5 and then positive 6.5. All right, that is it. And with the bonus of how to fix an error without having to erase the whole problem and start over. All right, so hopefully that helps. Again, pause, rewind the video. It should help. If you study the examples, and again, studying means looking at the examples until you, following the process until you truly understand what's going on. And so that comes from pausing the video, rewinding the video, and making sure that you have, again, a good understanding. So that's it for the examples for lesson 11.2. I'm sure you're going to do great on the work. And until the next video, take care and God bless.